There are more stars in the universe than grains of sand on all the beaches of Earth. More worlds than we could ever hope to count. And yet, we have only just begun to understand the depths of the cosmos. For thousands of years, humans have looked up at the night sky, asking the same questions. Where did we come from? Are we alone? What lies beyond the horizon of our understanding? From the ancient astronomers who charted the heavens, to the physicists of today who peer deep into the fabric of reality, one truth remains unchanged. The universe is a place of endless mystery. There are phenomena so strange, they defy our understanding. Dark matter, an invisible force binding galaxies together. Black holes, cosmic monsters from which nothing, not even light, can escape. The very nature of time and space. Could time travel ever be possible? Could there be parallel universes existing alongside our own? And then perhaps the greatest mystery of all. Are we alone? If the universe is so vast, why have we not yet found signs of intelligent life? In the next minutes, we will embark on a journey through the great mysteries of the universe, exploring the unseen forces that shape reality, the cosmic riddles that remain unsolved, and the possibilities that lie beyond our comprehension. With every question we answer, new ones arise, and perhaps some mysteries are meant to remain forever unsolved. The universe is not just a place we observe, it is a mystery we are a part of, and the greatest discoveries may still lie ahead. Chapter 1. The Great Unknown. The scale of the universe. How big is the universe? It's a simple question, yet the answer is anything but. For centuries, we believed the Earth was the center of everything. Then we realized we were just one planet, orbiting the Sun. Later, we discovered our Sun was just one of billions of stars in the Milky Way. And now, we know our galaxy is only one of trillions in the cosmos. But even knowing this, we are only scratching the surface of a much greater mystery. When we look up at the night sky, we are not seeing the universe as it is now, but as it was. Light takes time to travel, and the farther we look, the further back in time we see. The most distant light that reaches us today comes from around 13.8 billion years ago. The cosmic microwave background, a faint glow left over from the Big Bang. This forms the boundary of what we call the observable universe, a sphere about 93 billion light-years across. But the key word here is observable. Just because we can't see beyond this limit doesn't mean nothing exists there. In fact, most scientists believe the universe extends far, far beyond what we can detect. One of the greatest mysteries in cosmology is whether the universe is infinite or finite. If it is infinite, then no matter how far we travel, there will always be more galaxies, more stars, more planets stretching endlessly. If it is finite, then there must be an edge, a place where space itself comes to an end. But what would that even mean? What lies beyond such an edge? Some theories suggest the universe may be curved, meaning if you traveled far enough, you would eventually return to where you started, like walking in a giant cosmic loop. Others propose that our universe is just one of many, part of an infinite multiverse. If our universe is just one of many, then the true scale of reality is beyond imagination. Some scientists believe that the Big Bang did not create just one universe, but an infinite number of them, each with its own laws of physics, its own galaxies, perhaps even its own versions of you and me. Others propose that new universes are constantly forming through black holes, or that there exist parallel realities slightly different from our own, existing alongside us, but forever out of reach. If the multiverse is real, then everything we know, everything we see, may be just a tiny fraction of an unimaginably vast reality. Our brains evolved to understand the world on a human scale, things we can touch, see, and experience. But the universe operates on a scale so vast that even the greatest minds struggle to comprehend it. Every time we think we have reached the limits of knowledge, the universe humbles us, revealing even deeper mysteries. As we explore further into space, we are not just uncovering the secrets of the cosmos. We are redefining what it means to be human in an infinite and ever-expanding universe. But if the universe is so vast, what holds it together? Why do galaxies not simply fly apart? The answer lies in something we cannot see, something that makes up most of the cosmos: the invisible forces of dark matter and dark energy. Chapter 2: The Dark Universe, Dark Matter and Dark Energy. When we look up at the night sky, we see stars, planets, and galaxies, beautiful islands of light in the vast darkness of space. But what if we told you that everything we can see makes up less than 5% of the entire universe? The rest? It is hidden, invisible, yet it shapes everything we know. Scientists call it dark matter and dark energy, two of the greatest mysteries in modern physics. And their existence suggests that what we see is only a fraction of reality. In the early 20th century, astronomers noticed something strange when observing galaxies. According to Newton's laws of motion, the outer stars in a galaxy should move slower than those near the center, just like planets in our solar system. But that's not what they saw. Instead, these outer stars were moving just as fast as the inner ones, as if some invisible force was holding them in place. This shouldn't be possible, unless there was something else, something unseen, adding mass to the galaxy. This was the first evidence of dark matter, a mysterious, invisible substance that does not emit, absorb, or reflect light. And yet, it seems to make up around 27% of the entire universe. If dark matter cannot be seen, then how do we know it's there? Scientists detect it through its gravitational pull. It acts like an invisible glue, binding galaxies together and shaping the structure of the universe itself. But what is it actually made of? That remains a mystery. Some theories suggest it could be an unknown type of particle, unlike anything found in the standard model of physics. Others propose that it may be linked to black holes or even hidden dimensions of space. Despite decades of research, no one has ever directly detected a single particle of dark matter. And yet without it, the universe as we know it simply wouldn't make sense. The expanding universe, the mystery of dark energy. If dark matter is the glue holding the universe together, then dark energy is the force tearing it apart. For centuries, scientists believed that gravity would eventually slow down the expansion of the universe. But in the late 1990s, something shocking was discovered. The expansion of the universe isn't slowing down, it's speeding up. Some unknown force, called dark energy, is pushing galaxies apart, stretching the very fabric of space itself. And the strangest part, it accounts for nearly 68% of the universe. But what exactly is dark energy? Is it a property of space itself? A new fundamental force of nature? Or something even stranger? An unknown aspect of reality we have yet to understand. Dark matter and dark energy are locked in an eternal struggle, one pulling the universe together, the other pushing it apart. If dark energy continues to dominate, the universe may expand forever, growing colder and emptier with time. But if dark matter and gravity somehow regain control, the expansion could slow or even reverse, leading to a catastrophic event known as the Big Crunch, where the universe collapses back in on itself. Both scenarios could hold the key to understanding the ultimate fate of the cosmos. But until we truly understand what dark matter and dark energy are, we are left with more questions than answers. While dark matter and dark energy shape the cosmos, on the largest scales, there are other forces in the universe that are far more terrifying. Cosmic monsters lurking in the darkness, bending space and time itself. Next, we explore one of the most feared and mysterious objects in the universe, black holes. Chapter 3. The Enigma of Black Holes. There are objects in the universe so powerful, so mysterious, that even light itself cannot escape their grasp. They warp space and time, swallowing everything that comes too close. They are cosmic beasts lurking in the darkness, black holes. For centuries, black holes were considered nothing more than a theoretical curiosity, an idea too strange to be real. But today, we know they exist. We have even seen one. Yet, they remain one of the most puzzling and terrifying forces in the universe. What is a black hole? A black hole is a region of space where gravity is so intense that nothing, not even light, can escape. At its core lies a singularity, a point where all known laws of physics break down. They form from the deaths of massive stars. When a star many times the mass of our Sun reaches the end of its life, it undergoes a spectacular explosion, a supernova. But what remains after the explosion collapses in on itself, forming a gravitational prison from which not even the fastest thing in the universe, light, can escape. But not all black holes are the same. Some are small, only a few times the mass of our Sun. Others, known as supermassive black holes, are millions, even billions of times larger, sitting at the hearts of galaxies, including our own. Black holes have no solid surface, no boundary you can touch. Instead, they have an invisible border called the event horizon, the point beyond which nothing can return. If you were to fall into a black hole, time would slow down as you approach the event horizon. From the perspective of an outside observer, you would appear frozen, never quite crossing the threshold. But from your own perspective, you would fall freely, until you reach the singularity, where the very fabric of reality ceases to make sense. Scientists still don't know what happens inside a black hole. Some believe all matter is crushed into an infinitely small point. Others suggest that black holes could be gateways, portals to other regions of the universe, or perhaps even to different realities. At the heart of nearly every galaxy lies a supermassive black hole, millions or even billions of times the mass of our Sun. But how did they grow so large? Could they have formed in the earliest days of the universe? One of the most famous of these monsters lies at the center of our own Milky Way galaxy, Sagittarius A, a black hole 4 million times the mass of the Sun. Though it is 26,000 light-years away, its influence can be seen in the motion of nearby stars, which orbit it at incredible speeds. In 2019, scientists captured the first-ever image of a black hole, a glowing ring of light surrounding a dark abyss. This historic achievement confirmed what Einstein predicted over a century ago. For years, physicists have debated what happens to anything that falls into a black hole. Does it simply disappear forever? Or could there be something on the other side? Some theories suggest that black holes may be connected to white holes, the opposite of a black hole, where nothing can enter, only escape. If this is true, then black holes could be tunnels through space and time, natural wormholes leading to distant corners of the universe, or perhaps even to parallel realities. This idea is still purely theoretical, but if true, it could change our understanding of space, time, and the very nature of existence. The Fermi Paradox. Can black holes die? For a long time, scientists believed that black holes were eternal, consuming everything in their path. and never giving anything back. But in the 1970s, physicist Stephen Hawking made a shocking discovery. Black holes do leak energy, slowly evaporating over time. This phenomenon, now called Hawking radiation, suggests that black holes can eventually vanish, leaving behind nothing but empty space. But there's a problem. If a black hole disappears, what happens to all the information it swallowed? Does it vanish as well? And if so, does that mean information in the universe can be permanently lost? This is known as the black hole information paradox, one of the biggest unresolved mysteries in modern physics. Black holes challenge everything we think we know about space, time, and gravity. And as technology advances, we are only beginning to uncover their secrets. Future missions aim to study black holes up close, using gravitational wave detectors and advanced space telescopes. Some scientists even dream of one day sending a probe beyond the event horizon to see what truly lies inside. But for now, black holes remain among the greatest enigmas of the cosmos, a testament to the universe's power, mystery, and wonder. If black holes can warp space and time, then what does this tell us about time itself? Is time just an illusion? Could we one day travel through time, rewriting the past, or glimpsing the future? In the next chapter, we explore one of the most mind-bending concepts in physics, the mystery of time. Chapter 4. Time and Space. Is time travel possible? Time. It governs our lives, flowing forward in an unbroken stream. We measure it in seconds, minutes, years, yet we barely understand what it truly is. Is time an unchangeable constant, or is it something we could one day control? Could time travel ever become a reality? From Einstein's theories to science fiction fantasies, the concept of moving through time has fascinated humanity for centuries. But what does science say? Is it possible to travel to the future? Or even more controversially, could we ever return to the past? We experience time as a continuous flow, but physics tells a different story. According to the laws of nature, time is just another dimension, like length, width, and height. In theory, the past, present, and future all exist simultaneously, much like frames in a film reel. But why do we only experience time in one direction, always moving forward, never backward? The answer lies in a concept known as entropy. Entropy is a measure of disorder in the universe. Over time, things naturally move from order to chaos, from a neat stack of papers to a messy desk, from a hot cup of coffee to a cold one. This gradual increase in disorder gives time its direction, the arrow of time, forcing it to move forward. But could we ever reverse this process? Could we bend time to our will? Einstein's theory of relativity, time travel to the future. More than a century ago, Albert Einstein revolutionized our understanding of time with his theory of relativity. He showed that time is not fixed. It can speed up or slow down, depending on how fast you move or how close you are to a massive object. This means that time travel to the future is not just possible. It happens all the time. Astronauts aboard the International Space Station experience time slightly slower than people on Earth due to their high speed in orbit. This effect, known as time dilation, has been tested and confirmed through precise atomic clocks. The faster you move, the slower time passes for you. If we could travel at speeds close to the speed of light, time would slow down dramatically for the traveler, while continuing normally for those left behind. A spaceship traveling near light speed for what feels like a few years could return to Earth to find that centuries have passed. So, traveling to the future is scientifically possible. But what about traveling to the past? Going forward in time is one thing, but traveling back, That presents some of the greatest challenges in physics. The biggest problem is causality, the idea that cause comes before effect. If you could travel back in time, could you change the past? And if so, what happens to the present? This leads to famous paradoxes, such as the grandfather paradox. Suppose you traveled back in time and prevented your grandparents from meeting. If they never met, you would never be born. But if you were never born, who went back in time to stop them from meeting? These contradictions suggest that backward time travel may not be possible, or, if it is, there may be some unknown rule preventing changes to the past. One theoretical way to travel through time is through wormholes, hypothetical tunnels connecting distant points in space and time. According to Einstein's equations, wormholes could exist, acting as shortcuts through the universe. If one end of a wormhole was placed near a strong gravitational field, where time moves slower, and the other end was kept in normal space, stepping through could mean traveling into the past or future. But wormholes, if they exist at all, would be incredibly unstable, likely collapsing before anyone could use them. And even if we could stabilize one, it's unclear if it would allow for actual time travel. Some physicists suggest other ways to manipulate time. One idea involves cosmic strings, thin, ultra-dense filaments stretching across space, possibly left over from the early universe. If two cosmic strings move past each other at near light speeds, they could, in theory, bend space-time in such a way that a closed loop in time could be create a time machine of sorts. But even if such a phenomenon were possible, the energy required to manipulate these cosmic strings would be far beyond our current capabilities. If time travel is possible, then where are the time travelers? Shouldn't we have already met someone from the future? Some scientists argue that if time travel to the past were ever invented, it might only work from the moment the machine was first created, meaning no one could travel further back than that point. Others suggest that time travelers could be among us, blending in, or that any changes they make to the past create alternate timelines separate from our own. But so far, no real evidence of time travel has ever been found. For now, time travel remains the realm of theory and imagination. While the laws of physics allow for time to be stretched, slowed, and even theoretically bent into loops, no experiment has ever successfully proven that backward time travel is possible. Yet, the universe is full of surprises. What we believe to be impossible today may become reality in the future. After all, just 100 years ago, few could have imagined humans walking on the moon or sending robotic explorers to other planets. Perhaps one day, long into the future, a scientist will crack the code, unlocking the secrets of time itself. And when that day comes, we may finally answer the greatest question of all. Are we forever bound by time? Or can we break free? But there is another mystery tied to time, one that could change everything we think we know about our place in the universe. If time travel is possible, could other civilizations have already mastered it? If the universe is so vast, why have we not yet made contact? In the next chapter, we explore one of the most haunting questions in science, the search for alien life. Chapter 5. The search for alien life. Are we alone? It is one of the most profound questions humanity has ever asked. For centuries, we have gazed at the stars, wondering if other beings exist beyond our tiny world. With billions of planets scattered across the cosmos, surely life must have emerged elsewhere. Yet, despite decades of searching, we have found no definitive proof. The silence of the universe is deafening. Is intelligent life out there, hidden among the stars? Or is Earth truly unique? The Fermi Paradox. Where is everybody? In 1950, Physicist Enrico Fermi famously asked, "If the universe is so vast, where is everybody?" This simple question, now known as the Fermi Paradox, highlights the contradiction between the high probability of extraterrestrial civilizations and the complete lack of evidence for them. Our galaxy alone contains over 100 billion stars. Many of them have planets. Some of those planets are in the habitable zone, where conditions are just right for liquid water and potentially life. With so many opportunities, life should be common. And yet, we have not heard a single confirmed signal, found any alien megastructures, or encountered a single trace of intelligent beings. Why? In an attempt to quantify the probability of extraterrestrial civilizations, astronomer Frank Drake developed an equation that considers several key factors. How many stars have planets? How many of those planets could support life? And how many could develop intelligent civilizations capable of communication? The problem? Many of these variables remain unknown. Depending on what values you use, the equation suggests there could be thousands, perhaps millions, of civilizations in our galaxy. Or we could be completely alone. The search for exoplanets, worlds beyond our own. For most of human history, we had no proof that planets even existed beyond our solar system. That changed in 1995, when astronomers discovered the first exoplanet orbiting another star. Since then, we have found thousands. Some of these worlds are remarkably similar to Earth. Rocky planets orbiting their stars at just the right distance for liquid water. Others are stranger than we ever imagined. Planets made entirely of ice and gas, or worlds where rain falls as molten iron. Among these exoplanets, scientists search for signs of habitability. Could an Earth-like world somewhere out there be home to alien life? Finding a planet in the habitable zone is just the first step. The next challenge is detecting biosignatures, chemical markers in a planet's atmosphere that suggest life is present. On Earth, our atmosphere contains oxygen and methane, both of which are byproducts of living organisms. If we find similar gases on another planet, it could be a sign that life exists there. But what if we are not just looking for microbes? What if there are advanced civilizations out there? In that case, scientists search for technosignatures, evidence of artificial structures, radio signals, or even energy emissions from advanced alien technology. So far, no conclusive evidence has been found, but that does not mean we are alone. Mysterious signals. Are aliens trying to communicate? Throughout history, there have been a few intriguing signals that sparked excitement. In 1977, astronomers detected a powerful, unexplained radio burst from deep space, known as the WOW signal. It lasted for 72 seconds and has never been repeated. More recently, astronomers have observed fast radio bursts, brief, intense flashes of radio waves from unknown sources. Could these be natural cosmic events, or could they be distant civilizations trying to reach out? Scientists remain cautious. Many signals once thought to be alien in origin turned out to be natural cosmic phenomena. But the search continues. If life is common in the universe, then why haven't we found any evidence of intelligent civilizations? One possible explanation is the Great Filter, a mysterious barrier that prevents civilizations from advancing beyond a certain stage. This filter could exist at the very beginning, making the emergence of life extremely rare. Or it could come later, in the form of self-destruction, preventing civilizations from surviving long enough to explore the cosmos. If the Great Filter is behind us, then we may be among the lucky few to have made it this far. But if it lies ahead, then our greatest challenge may still be waiting. Could they be watching us? Another possibility is that alien civilizations are out there, but they are simply choosing not to reveal themselves. This idea is known as the zoo hypothesis, the possibility that more advanced beings are observing us, much like we observe animals in the wild, without interfering. Alternatively, aliens may exist in a form beyond our understanding, perhaps as highly evolved artificial intelligences or beings that no longer rely on physical bodies. If they are there, how would we even recognize them? If we ever detect an alien signal, how should we respond? Should we attempt to communicate, or should we remain silent? Some scientists warn that revealing our existence to an unknown civilization could be dangerous. We have no idea if extraterrestrial life would be friendly or hostile. Others argue that if advanced civilizations exist, they would likely already know we are here. For now, we listen, we watch, and we wait. The search for alien life is one of the greatest scientific quests of our time. Every new discovery, every exoplanet, every unexplained signal brings us one step closer to answering the ultimate question: are we alone? Perhaps one day we will receive a message from the stars, or perhaps we will set foot on another world and find life staring back at us. Until that day comes, we can only look up and wonder. But what if the universe itself is not what it seems? What if everything we know, everything we see, is nothing more than an illusion? In the next chapter, we explore one of the most mind-bending theories in modern science, the simulation hypothesis. Chapter 6. The simulation hypothesis. Are we living in a virtual universe? What if everything you know, your memories, your experiences, the very fabric of reality, is not real? It may sound like science fiction, but some of the world's greatest minds are seriously considering the possibility that we are living inside a simulation, an artificial world designed and controlled by an unknown force. If this is true, then our universe is not what we think it is. Reality itself may be nothing more than a highly advanced illusion. The idea behind the simulation hypothesis. The idea that reality is an illusion is not new. Ancient philosophers from Plato to Descartes questioned whether what we perceive is truly real. But in recent years, this idea has evolved from philosophy into a scientific hypothesis. In 2003, philosopher Nick Bostrom proposed the simulation argument, a theory suggesting that a sufficiently advanced civilization could create a simulated universe, complete with conscious beings who do not realize they are inside a simulation. If such technology were possible, it raises a startling question. How do we know we are not inside one of these simulations right now? Are we just a computer program? Think about a video game. At first, games were simple, pixelated images on a screen. But as technology advanced, they became more realistic, with vast open worlds, artificial intelligence, and detailed physics simulations. If technology continues to improve, future civilizations might create simulations so advanced that the characters within them would believe they are real. From the perspective of those inside the simulation, everything would seem natural, just as our world seems to us. They would feel emotions, have thoughts, and even create their own science, never realizing they were part of a computer program. If a civilization could create one simulated universe, they could create millions, perhaps billions. That means the number of simulated realities could vastly outnumber real ones. If that is the case, statistically, it is more likely that we are in a simulation than in the one real universe. Possible evidence that we are in a simulation. Is there any proof that we are living in a simulation? While no direct evidence exists, some strange aspects of the universe hint at the possibility. 1. The limits of reality. Just like a video game has rendering limits, The universe seems to have boundaries. Space and time are not infinitely smooth. They are made up of tiny, discrete units, like pixels in a digital image. Could this be a sign that our world is rendered on a cosmic scale? 2. The laws of physics resemble computer code. In 2012, theoretical physicist James Gates discovered something astonishing, hidden deep within the equations that describe the universe. He found a type of computer code called error-correcting codes, similar to what we use in digital computing. Why would the universe have built-in error-correcting mechanisms? Could it be that we are inside a programmed reality? 3. The fine-tuning problem. The laws of physics are incredibly precise. If any of the fundamental forces were slightly different, stars wouldn't form, planets wouldn't exist, and life would be impossible. Some scientists believe this precise tuning suggests a designed reality rather than a random one. If we are in a simulation, who created it? If we are in a simulation, then the next question is, who or what created it? There are many possibilities. It could be an advanced alien civilization, millions of years ahead of us, in technology, running simulations of past civilizations for research or entertainment. Or perhaps it was created by our own distant descendants, future humans who have developed the ability to simulate their ancestors to better understand history. And then, there is the most unsettling possibility that the creators themselves are also simulated, living inside yet another simulation, part of an infinite chain of realities within realities. If we are in a simulation, is there a way to break free? Some theorists suggest looking for glitches, anomalies in the universe that defy explanation. Others propose that if we one day create our own simulations, we might discover clues left behind by our creators. But if we are simulated, does it even matter? If we feel emotions, experience beauty, and search for meaning, does it change anything if our reality is artificial? Perhaps in the end, reality is defined not by what it is made of, but by what we experience within it. Whether we are in a simulation or not, one thing is certain: the universe is full of mysteries beyond our understanding. And perhaps the greatest mystery of all is what will happen to the universe itself. In the next chapter, we explore the ultimate fate of everything, the end of time, the death of the cosmos, and what might come after the universe itself ceases to exist. Chapter 7. The Fate of the Universe. How will everything end? Everything that begins must one day come to an end. Stars burn out, galaxies collide, even the universe itself is not eternal. But how will it all end? Will the cosmos fade into darkness, collapse upon itself, or could something entirely unexpected happen? To understand the universe's fate, we must first understand its past and the forces that continue to shape its future. The expanding universe, a race against time. For billions of years, the universe has been expanding, stretching space itself outward. This discovery, made in the early 20th century, changed everything we thought we knew about the cosmos. But what is driving this expansion, and will it continue forever? Scientists once believed that gravity would eventually slow the expansion, perhaps even reversing it. But then, in the 1990s, something unexpected was discovered. The universe isn't just expanding, it's accelerating. This means the future of the universe is controlled by a mysterious force, dark energy, a force that may determine how everything will end. Scenario 1. The Big Freeze, a cold, empty universe. If dark energy continues to accelerate the expansion of the universe, then galaxies will drift farther and farther apart. Over time, stars will burn out, leaving behind only dead remnants, cold white dwarfs, neutron stars, and black holes. Eventually, even the last light will fade. The universe will grow darker, colder, and more empty. This is known as the Big Freeze or heat death. In this scenario, the cosmos does not end in fire, but in eternal darkness. No new stars will form. No new life will emerge. The universe will become a vast, silent void, frozen in time, with only black holes slowly evaporating over trillions upon trillions of years. It is the slowest, most inevitable kind of death. Scenario 2. The Big Crunch. The universe collapses. But what if the expansion doesn't continue forever? What if one day, dark energy weakens and gravity takes control? In this scenario, known as the Big Crunch, the universe stops expanding and begins to contract. Galaxies start moving toward each other. Space itself collapses inward. Over billions of years, everything is drawn together: stars, planets, entire galaxies, until all matter is crushed into an unimaginably dense point, similar to how the Big Bang began. Some scientists speculate that this could lead to a cyclical universe, where the Big Crunch triggers a new Big Bang, restarting the cosmos over and over again in an infinite cycle of creation and destruction. But is this really the end, or just another beginning? Scenario 3. The Big Rip, tearing the universe apart. There is one more possibility, perhaps the most terrifying of all. What if dark energy doesn't just continue pushing the universe apart, but accelerates beyond control? In this scenario, known as the Big Rip, dark energy grows stronger over time, eventually tearing apart galaxies, stars, and even atoms themselves. First, galaxies separate. Then, solar systems unravel. Planets are stripped from their star. Even molecules and atoms are torn apart, until all that remains is a featureless sea of radiation. The universe would not fade into cold darkness or collapse upon itself. Instead, it would be ripped apart at the most fundamental level, leaving behind nothing. If the Big Rip is correct, it could happen in as little as 22 billion years. And when it does, time itself may cease to exist. Could the universe reboot itself? But is destruction truly the end? Or could something exist beyond it? Some theories suggest that even after the universe ends, new universes may emerge. Quantum physics suggests that space is never truly empty. Even in the void, fluctuations could create new bursts of energy, leading to another Big Bang. This could mean our universe is just one in an endless cycle, a cosmic phoenix that rises again and again from the ashes of its own destruction. Or perhaps, the universe as we know it is just one of many, a single bubble in a vast multiverse, where new realities are constantly forming beyond our reach. The end of the universe is inevitable. But what does it mean for us, here and now? For humans, our time in the cosmos is brief, a flicker of light in an ocean of eternity. But that does not make our existence meaningless. If anything, it makes it even more precious, because in this vast and mysterious universe, we are able to wonder, to ask, and to seek answers. We are made of the same elements as the stars. We are, in a way, the universe itself, trying to understand its own story. And perhaps, the greatest mystery is not how the universe will end, but what we do with the time we have. We have explored some of the greatest mysteries of the cosmos, from the unseen forces of dark matter to the enigma of black holes, from the question of alien life to the possibility that our reality itself is an illusion. Yet, the universe continues to surprise us. With each discovery, new questions arise, and the more we learn, the more we realize how much remains unknown. But that is the beauty of science, the endless search, the thrill of uncovering the secrets of the cosmos. And though we may never find all the answers, one thing is certain: the journey is only just beginning. The universe is vast, mysterious, and full of wonders. And as long as we continue to explore, to ask, and to dream, we will always be a part of its great story.